This question involves what's called kinematics. We've got a particle that's given by the formula x equals t squared minus 7t plus 12, and we're asked to find its initial position at t equals 5, its initial velocity, when its velocity equals 0, and what position is it at that time, and then its average velocity and speed over the first 5 seconds. So the skills we're going to need to use here all involve differentiation and just interpreting what the question is actually asking us to do. So first question, part A, says its initial position, and so that little hint there, initial tells us that t is equal to 0. Alright, we're measuring from t is 0 or greater. So initially t equals 0, so we sub that into the x formula. So x at 0 is equal to 0 squared minus 7 plus 12, which is 12 centimeters away from the origin point. The second question says where is it at t equals 5, so we do the same thing, we're just subbing in 5 for t. So x at 5 would equal 5 squared minus 7 lots of 5 plus 12 gives us 25 minus 35 is negative 10 plus 12 gives us 2 centimeters. Part C says find its initial velocity. So initial, again, t equals 0, and this time we're trying to find its velocity, not its position. So velocity is the change in distance over the change in time, or dx dt, the derivative of the x formula. So we derive our original equation. So we'll get 2t minus 7, and we're going to say initially, that would mean that t is 0, so we'd get the initial, or v at 0, is equal to negative 7 centimeters per second. Part D is saying when does its velocity equal 0? So when does v equal 0, and what is its position at this time? So we'll end up finding the x value when the velocity is 0. So let's use our velocity formula, which was 2t minus 7, and set it equal to 0. And we can rearrange to get t by itself. So t would equal 7 on 2 seconds, or 3.5 seconds if you want to work in decimal places. Then we need to sub that into our x formula to find x. So x at 3.5 is equal to 3.5 squared minus 7 times 3.5 plus 12 would give us negative 0.25 centimeters. So we're negative 0.25 away from our origin or starting point. The last two questions seem quite similar. We're just looking at the difference between velocity and speed. Now, when we're looking at the average velocity, we want to find the change over the first 5 seconds in the velocity. So the average velocity, we can say is similar to our gradient formula. We're actually looking at the x, or the distance at the endpoint. So it was 5 minus x initially over the initial t, or the change in t, so which is 5 minus 0. We know these x at 5, we know from part B, was 2 centimeters, and initially x was 12 centimeters from part A, so we can go 2 minus 12 over 5, we get negative 10 divided by 5 equals negative 2 centimeters per second. And we notice that velocity, being negative, tells us the direction in which it's traveling. I'm going to sketch the position of the particle over time. I'm just going to use a horizontal axis here. So there's our origin, starting sort of reference point, and we know when t equaled 0, x was at 12 centimeters away from it. Then we went to 3.5 seconds later, we noticed it got down to negative 0.25. So the particle moved this direction, and it stopped there, because that's what was our first stationary point for part C. Then at 5 seconds, it had gone back to 2 centimeters away from the origin point, and it was positive 2. So we're back up to here. So the particle's actually traveled for 3.5 seconds, stopped, and turned around. So when we look at part F and we want the average speed, we want to say the total distance divided by the time traveled. So total distance divided by time, in this case, is going to be for the first 3.5 seconds, we traveled from 12 to negative a quarter. So we're traveling 12.25 centimeters. And then from 3.5 seconds to 5 seconds, we traveled back to positive 2. So from negative a quarter to positive 2, we're traveling 2.25 centimeters. And we traveled for a total of 5 seconds. So we'd get 14.50 centimeters divided by 5 seconds, which would give us 2.9 centimeters per second.